Hello guys, this is CodeNCode and this is the fourth lecture of this dynamic programming part 2 series. And in this lecture we are going to solve this problem. Let's go rolling. Taken from Codeforces. This is a dynamic programming problem. So the problem is we are given some marbles. We are given some marbles on the x-axis. Their coordinates are x1, x2, x3 dash 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 xn. So these are their coordinates, and these can be unsorted as well. So let's assume that the size of the each marble is negligible, so you can consider them as points on x-axis. So assume to be a point. There are two things you can do. Either you can stick points in some of them. So you can stick pins in some of those marbles. So what you can do, the property of marble is that it moves towards the left. So what you can do, you can pin down the marble, the ith marble, or you can leave it as it is. So what would happen if you pin down the ith marble? It won't move towards the left, but every marble that was on the right of it, if you don't pin them down, what would happen? They would start rolling towards the left, and at some point they would reach the ith marble and they would stop there at that point. So if I explain you with an example, suppose there was a marble at position 1, 4 and 5. So if you pin down the marble at position 1, so 1 won't move towards the left, but the marbles at position 4 and 5 would move. So what would happen? They would move and eventually they will reach marble at position 1, since they were moving towards left. Now at the point where the marbles at position 4 and 5 would reach position 1, they won't be able to go towards left because the marble at position 1 is pinned, so you can't move it towards the left. So the position of every single marble, the marble at position 4 and 5 would also be 1 finally, because they would move towards the left and at some point they would reach position 1. So position of marble which was initially at position 4 would be 1, and the one which was having position 5 would also be 1. So this is what happens. So either you can pin some of the marbles, and the cost of pinning is given. Cost of pinning the ith marble is Ci, and special thing is that Ci can be negative as well. So we have to choose some of the marbles and stick them. So as we know, if we pin them, there is some cost, so we have to minimize the cost. There are two costs. First, the cost of sticking some of the marbles or pinning some of the marbles, because we decide to pin. Suppose there were 10 marbles, we decided to stick 2 or 3 marbles. So let's say we decided to pin down 3 marbles. Then the total cost would be the sum of the cost of those 3 marbles, the CIs of those 3 marbles, plus the second thing is, if there were 2 marbles, one at position 5, one at position 1, you pin down marble at position 1, then 5 would move 4 different positions. 5 would move from 5 to 4, 3, 2 and then finally 1, and then it won't be able to move towards left, right? So 5 has traveled 4 unit of distance, so that would add into your cost. So that would also add into the cost. So we have to minimize the total cost. One more thing, if a marble, as we know, moves towards the left, if there is no marble which is pinned, suppose the ith marble starts moving towards the left and there is no marble on the left of it which can stop it, then it would move towards the infinity. So what would happen? This would cost us infinity. So we won't want that, of course. So it is always necessary for us to pin at least the leftmost one, because if we don't, then the leftmost marble would keep moving and the total cost would be infinity. So we want that because we want to minimize the total cost. If you take the example, there are three marbles. This is their coordinate and this is their cost. So there is a marble at coordinate 2. If you pin it down, the cost is 3. There is marble at position 3, cost is 4. Position 1, cost is 2. So first thing that we would do, first we would sort them. So that we can decide which is the leftmost one, and for the next element which is the previous one. So the thing about previous I would explain. So what is happening here, I've sorted all of these are the coordinate, these are their cost. So at position 1, there is a marble whose cost is 2 if you pin it down, and all the coordinates are unique. At position second, there is a marble. At position second, there is a marble whose cost is 3 if you pin it down. At position 3, the cost would be 4. So the optimal answer is 5, and the optimal way is to only pin down the first one. If you pin down the first marble, then it will stick its position and the cost would be 2. The second one, since we are not we are not pinning it down, so this won't add into our cost. But since the marble at position 2 have to travel 1 unit of distance, because it would move from 2 to 1, but from 1 it won't be able to move, it won't be able to pass 1 because 1 it stuck at its position, so 2 won't be able to pass 1. So 2, the marble which was at position 2 would have to travel distance 1, which is the absolute difference between the previous marble which was stuck. So this was at position 1 minus the current position, so it would add +1. Same goes for same goes for the marble which is at position 3. This is its x coordinate. So since we are not pinning it down, so this won't add into our cost. But since it have to travel 2 unit of distance, because current distance is 3 minus the previous marble position of previous marble, which is 1, so 1 minus 3 is 2, so the overall cost comes out to be 5. So if you have studied in dynamic programming the subset problem, this problem is no different than that. So what we are going to do first, this is the problem, this thing, and the number of marbles can be as large as 3000. Cost can be negative or positive, and their coordinate and the cost can be -10⁻⁹ to +10⁻⁹. Important thing for us for now is this: number of number of marbles are not more than 3000. So let's create an array. Since we want to sort them based on their x-axis, so we would create array of pairs, because at each position I want to store two things: its x coordinate and its price, its cost. So array of 3000 of pair. So int n, then first thing, let's just take input. So the first thing is its position, so ar dot first. So now what would happen, at each position you are having a pair which can store integer and integer, pair of integer and integer. So what it tells, that at first position you are going to get an integer, at second also you are going to get an integer. So at first I would be saving the x coordinate, so that is why ar of I dot first, I am taking the first input, and Now at this is how I am saving. So this is x and this is c of I. This is how we are creating a pair. So the first thing is x coordinate and second thing is its cost. Now just sort it. So AR of 1, AR of n plus 1, since there are n number of elements. So this is how you sort an array. Since we are starting taking input from position 1, that is why base address plus 1, and then there are n number of elements in total, so base address plus 1 plus n. If you are using 0 base index system, then simply replace 1 with 0. Now this is sorted. Now since we are using the sort function, so it would first sort based on the first thing, first element in the pair. First element is x-axis or x coordinate, that is why it would be sorted based on x coordinates. Second value would be used only to break ties. So all of the elements are sorted in x-axis. Now let's simply answer. Let's create a function get answer. So before I pass anything, let's think what we need in get answer function. So first of all, oh yeah, let's keep n here so we can decide whether we are at the end of the position or not. First thing that we need in the get answer function is, of course, a position to decide a position of the marble. So currently we are at the 0th. I'm talking about the index, not the x coordinate. So this was my alarm. So I'm talking about the index in the array, not their x coordinate, since x coordinate can be negative 10 to the power 9 to plus 10 to the power 5. So I'm talking about the index. So the first thing you need to pass is the index of the marble for which we are going to decide what would happen. So as I said previously, that this problem is no different than subset sum problem. So what we do in subset sum problem is this: at each position, first we need the position of the element for which we are going to decide, and for that element we have two choices. First, either to include this element into our sum or don't. If you include, the result would be pos plus 1, because for position pos you have already decided what to do, and since you have included it into the sum, so it would be sum plus weight or value, whatever you want to call it, value of current element, because you have chosen to add this into your subset. If you want to ignore this element, so the transition would be pos plus 1, because for the pos element you have made your decision to ignore it. If you ignore it, then sum would be as it is and there would be nothing to do. So these are two transition when we solve for subset sum problems. Now for this problem, if you see, there are only two transition for this problem as well. For each marble we have two choices: either to stick it or pin it, or to leave it as it is. So if you would, so first thing is that we need the position, because there are n elements. For each element we need to decide whether to pin it or to leave it. So we need the position so that we can decide for each element whether we want to leave it or pin it. So there are two conditions, right? So first thing, let's define the base condition, and that would be if pos is greater than n, which means there were n elements, and now we have decided for all of those n elements. That is why we are above n. So we would simply return 0, because if there are no marbles, there is no cost. Now if you are on POS and POS is less than equals to n, which means we are currently deciding for the this for yeah, for this element, whether to make it, whether to pin it in X. This would be the cost of pinning. If we pin it down, then this would be the cost, and to leave it as it is, so this is the cost to leave it as it is, right? And if only two transition or two options we have, either to pin it or leave it, and now we would return the minimum of it. X is the cost if we pin it down, y is the cost if we leave it as it is. So of course we want the minimum, so we would choose that condition which minimizes the sum. So we would take the minimum of those two costs and we would return it. Now the question is how to calculate the cost if you pin it. Of course, if you pin this element, the cost is going to be AR of I dot second, which is the cost of pinning the the POS. This is the cost of pinning the current element, right? After pinning, you want the cost, or you want to make decision for the rest of the elements. So you would make get answer function call for POS plus 1, right? This is the cost if you pin it down. You can calculate it using this transition, but the important transition is this. Why? What happens if you leave it as it is? If you leave the current marble as it is, it would start moving towards the left till the point it reaches the first position, the first marble towards the left of it, which was pinned down. So if what I want to say is that if I decided to leave it as it is, the third marble, then it would keep moving towards that marble which is the nearest one to this marble and which was pinned down. So we know that this marble wasn't pinned down, so it would keep moving towards the left, and since we know this marble was pinned down, so it would keep moving towards this one. And then the total cost it would add is position of the marble which was pinned minus absolute difference of position of this marble, I mean the x coordinate of this marble minus x coordinate of this marble. So if you leave ith marble as it is, then it would keep moving towards the first marble which is nearest to this one which was pinned down. So the first marble which is nearest to marble 3 is marble 1. So to decide how much cost it gives us, we must know which was the previous marble which was pinned down, and hence we must know the previous one. And that is why in our get answer function we must need one more thing, and that is the index of the previous marble which was pinned down. So this is the index of the previous what we call it, previous marble which was pinned down. Now we can calculate the cost. If we leave the current marble as it is, so it would keep moving towards the previous marble and would stop at that position. So how much position does it moves? So it moves the absolute difference between the x-axis of first x coordinate of current marble minus x coordinate of the marble which was pinned down previously. So this is the marble, this is the index of the marble which was pinned down previously. So AR of pre dot first. So now what we are doing here, we are taking the cost if I leave this marble as it is. So it would keep moving towards the left till it reaches the previous one which was pinned down. So how much distance would it travel? Of course the distance would be the x-axis of the current marble minus the x-axis of the previous marble. though since all of these are sorted, so x-axis of current would be greater than the x-axis of previous, so you can replace you can remove absolute, but it doesn't matter. I mean, not going to increase complexity, so I don't care. So this is the cost if you leave it as it is. Now for the current marble, we have made the decision. Now we are left to make the decision for the marble from position pose plus 1 to n. So that is why we would make get answer function call to pose plus 1, and then what we would pass as previous. Now since uh, this current marble has not been pinned down, so the previous is not changed. The previous one which was pinned down, that is still the previous. What I want to say is that it will be clear in this one. Now if you pin the current element down, what would happen? Now this element, it is not the previous anymore, because suppose this was initially the previous was uh, the marble at index 1, and we are currently pose, this is pre was 1, that is the marble at index 1 was previously pinned, right? And we are at position 3. Now we have decided to pin it down, the marble at position 3. So for elements which are coming next, that is for element at index 4 to n, for those, if you pin it down this marble, then for those previous would be position 3, not position 1, right? So that is why if you pin the current element down, so the previous would become the current element for the upcoming marbles. So as previous, you would pass the index of current element, because we are pinning it down. So this element is the previous for the upcoming marbles, that is why we would pass POS. But if we are not pinning it down, then the previous doesn't change. If you don't pin it down, then for the elements which are coming next, for those previous is still the same, that is why we are passing the same previous. So this is how you solve this problem, and this is how we design the dynamic programming problem. All you have to do is think for a current state, what options do we have? We only have two options, either to pin it down or to let it go. If you pin it down, this would be the cost. If you let it go, this would be the cost. And since we have to minimize, so we would return the minimum cost. If I from the main function, we have to pass coordinates, of course, right? We have to pass positions. So what you can do, you can pass position 1, because we have to make decision for all of the elements starting from position 1. And what would you pass as previous? Because previous means the previous element which was pinned down. What would you pass here? Just think for a second. In fact, we don't have to pass 1, because we don't have to make decision for the first element, because we know the first element, that is the leftmost element, have to be pinned down no matter what. If you don't do this, this would keep moving towards the left, towards infinity, and hence the total cost would be infinity, and that is what we don't want. So we are 100% sure that the first element needs to be pinned down. So we have to make decision from index 2 onwards, right? For the marbles from second marble to the nth marble, because we don't have to make decision for the first marble, because we know the first marble we have to pin down no matter what, otherwise the cost is going to be infinity. So we have to make decision for the element from 2 to n, and that is why I'm passing the index 2. And then what is the previous element which was pinned down? Of course, the first marble. So if you pin down the first marble, the cost you need to add is AR of 1 dot first, which is second, which is the cost of pinning down the first marble. So this is going to be solution, this is going to be your answer. You can simply print answer. So let's simply run this. There are two test cases, we would run for each of them. First, let's see whether we get any error. Yeah, n seen. Oh, sorry. Okay, now we are up and running. Let's see the test cases. This is the first test case. So the answer is 5. As you can see here, it is the 5. For the second test case, (11), as you can see 11, but the current complexity is exponential because for each position we are making two different choices, either to let it go or pin it down. So the overall complexity currently is exponential, and you all know how to convert it into DP. We would take an array or memoization table, and it would be a 2D DP because we have two states, two parameters in our get answer function. So first one would be for POS, position can't be greater than 3000 because there are 3000 elements. So first would be dimension of position, and other one is dimension of other one is storing the previous is again a index which can't go beyond 3000 because there are 3000 elements. So before how we do it, we simply check if dp of pose and pre is not equals to -1. We are going, oh, just a second, we can't initialize it with -1. What we do, we initialize all the elements of dp with something, but we can't initialize it with -1. The reason, the result itself can be -1 because you see the cost can be negative, so it can be -1. uh, in fact, we can't initialize it with -1, -2 or anything because the overall sum of xi's, sorry, the overall sum of ci's can be minus for each one. First of all, there can be 3000 element, each one can have minus 10 to the power 9 cost. If you add all of these, the overall cost is going to be 3 into 10 to the power 12 minus 3 into 10 to the power 12. So we can't use anything, in the range of minus 3 into 10 to the power 12 to plus 3 into plus 3 into 10 to the power 12. In this range you can't use any element to decide whether this is invalid state or not. So what we are going to do, we are going to define something called infinity const infinity, and we would take the value to be 10 to the power 15, 16, because you can't take a value in this range, minus 10 to the power minus 3 into 10 to the power 12 to plus 3 into 10 to the power 12. So I'm going to use 10 to the power 15. So this is 10 to the power 15. So if this dp of pre-pose is not equal to minus infinity indicates the invalid state. So if the dp of this one is not equal to minus infinity, which means we are currently, the dp of pre and pose and pre currently holds the result, or this state is already been processed. So we would simply return this. Otherwise we would calculate the result like this, and before returning we would save it into our dp. And before making this function call, we need to initialize all of the elements of the dp. You can use memset, but I use this, I don't know why. D less than equals to n, d plus plus, initialize each element of dp with minus infinity, which indicates invalid state, or the state which is not been reached or traversed. So inf, I have already defined inf, so I have to remove that. I hope this works. My legs are numb. So this is the test case. This is the test case. Copy, paste. The result is again 5, which means till now at least everything's fine. For the second test case, the result should be 11. So second test case, the result is 11. So this is working at least for now. For the sample test cases, this is working fine. So let's remove this line before submitting. This is nothing you worry about. This is just an extra code I write. to make the font bigger. Let's go submit this. Okay, there is a problem, I guess, because the result, the overall cost can be greater than 10 power 9, and 10 power 9 is roughly the limit of integer, so we need to return long int instead of int. So I'm not going to write long int each time. I'm simply going to write lli. I have already defined to be somewhere, yeah, here. Lli would be replaced with long int itself. So okay, everything is fine there. Answer should be lli as well, and everything's fine now. Let's see if it still compiles. Yeah, everything fine. So replace the code with the current one and submit. Okay. AC. So this was all for this problem. This was let's see. This was E problem rated 1800 DP from Codeforces. So this was all for this lecture. Thank you guys for being a great audience and being with me. So thank you guys for watching. Until the next video drops, keep coding. Thank you.